Minsk, Belarus, 1959. Inside the cavernous assembly hall of the Minsk Automobile Plant, welders spray sparks across a chassis that dwarfs anything the facility has produced before. The MAZ-five 37 is taking shape. 8 massive wheels, each nearly as tall as a man. A cab fortified like a bunker, and beneath the hood, a 38.8-liter V12 diesel engine derived from Soviet tank engine designs, generating 525 horsepower of raw pulling power. This is not a truck. This is a statement. The MAZ-five 37 could haul 50-ton trailers across terrain that would swallow conventional vehicles. It could tow a T-54 tank through Siberian mud. It could drag ballistic missile launchers across frozen steppes where roads didn't exist. Soviet engineers had built a machine capable of moving the heaviest military hardware anywhere, anytime, without depending on railroads or paved highways. Meanwhile, 5,000 miles west, American military planners were solving the same problem with a completely different answer. The United States never mass-produced a direct equivalent to the MAZ-five 37. Not because American engineers couldn't build such a machine. They could. They simply didn't need to. The reason reveals everything about how two superpowers with similar problems chose radically different solutions based on geography, infrastructure, doctrine, and strategic priorities. This is the story of why America built highways while the Soviets built monster trucks. The MAZ-five 37 entered service in 1959 as the Soviet military's solution to a problem that had haunted them since World War II. During the war, Soviet tank units had been forced to drive their T-34s hundreds of kilometers to the front on their own tracks. The result was catastrophic. Tanks broke down, track links wore out, engines failed. By the time units reached combat, mechanical attrition had already reduced their strength by 20 to 30%. After 1945, Soviet planners determined this would never happen again. The MAZ-five 37's specifications were staggering. The 38.8-liter V12 diesel produced 525 horsepower. The hydromechanical transmission provided 8 forward gears and 2 reverse. All 8 wheels were driven, with massive low-pressure tires designed to distribute weight across soft terrain. Ground clearance exceeded 400 millimeters. A built-in winch on the MAZ-five 37G variant was capable of pulling over 20 tons, often more with pulley rigging, allowing the truck to recover stuck vehicles or haul itself out of deep mud. Military historian James Kinnear documented that the MAZ-five 37 gave Soviet armored units much greater strategic mobility than railroads alone could provide. Tanks could be carried by road to where they were needed quickly without grinding down their tracks or being limited to railway timetables. The truck's load rating was initially 50 tons on a semi-trailer, later increased to approximately 65 tons. This was sufficient to carry a T-54, T-55, T-62, or later T-72 tank on a special low-bed trailer. But the MAZ-five 37's role extended beyond tank transport. The chassis became the foundation for mobile ballistic missile launchers. Some Scud missile systems used MAZ family 8x8 trucks as mobile platforms. Heavy surface-to-air missile batteries were mounted on MAZ-E chassis. Soviet military planners had created a universal heavy-haul platform that could move anything the Red Army needed to move, anywhere Soviet forces might operate. The MAZ-five 37 represented fundamental Soviet military doctrine, the ability to surge heavy forces across vast, possibly infrastructure-poor distances if necessary. The United States approached the heavy transport problem from an entirely different direction. During World War II, American forces fielded the M-25 tank transporter, nicknamed the Dragon Wagon. This combined a 6x6 armored tractor with a 40-ton payload trailer powered by a 240-horsepower gasoline engine. American forces used it extensively in Europe to retrieve or reposition tanks without forcing them to drive on their own tracks. In 1955, the U.S. Army retired the M-25 and introduced the M-123, a 10-ton 6x6 semi-tractor built by Mack Trucks. It was designed to tow 60-ton tank transporter trailers, initially using a massive V8 gasoline engine producing roughly 300 horsepower. The M123 could haul the new generation of heavier tanks like the M48 Patton, but it was fundamentally a conventional front-engined truck, not an all-terrain monster like the MAZ-five 37. The M123 primarily operated on roads or prepared routes. The U.S. Army used it extensively during the Vietnam War, and it remained in service into the 1990s. The United States did experiment with MAZ-like designs. In the late 1960s, a joint U.S.-German project led to the M746 heavy equipment transporter, an 8x8 heavy tractor with a 625 horsepower engine. Only about 125 M746 trucks were built for U.S. Army Europe in the 1970s. It wasn't until 1992 that the United States fielded a truck truly comparable to the MAZ-five 37. The Oshkosh M1070. Heavy equipment transporter was an 8x8 tractor built specifically to carry the M1 Abrams tank, which weighed 68 tons. The M1070 featured a 500-horsepower Detroit diesel engine, upgraded to 700 horsepower in later versions. But this came more than 3 decades after the MAZ-five 37's debut. Why did America wait so long? The Soviet Army emphasized ground mobility for moving heavy forces internally across its vast landmass. Soviet military doctrine anticipated scenarios where tank armies might need to redeploy quickly overland, from deep inside the USSR to the front in Europe or Asia, even if railways were unavailable or destroyed. U.S. military doctrine placed fundamentally different emphasis. American planners focused on airlift and sea lift for long-range deployment. NATO expected to fight near prepared logistics hubs, not conduct 1,000-kilometer road marches on short notice. The United States invested in the C-5 Galaxy transport plane, introduced in 1970, capable of flying tanks overseas. The C-5 could carry over 100 tons of cargo over intercontinental distances at 500 miles per hour. A MAZ-five 37 could haul 65 tons at 30 miles per hour over land. Different tools for different strategic concepts. The Soviets, until the introduction of the Antonov An-124 in the 1980s, had very limited ability to airlift heavy armor. They doubled down on ground transport because that was their strength and their necessity. Heavy trucks were used by the U.S., mainly for shorter distances, from port or railhead to the front, reducing the need for an all-terrain behemoth. The United States mainland has an extensive network of quality roads and railroads, as did Western Europe. In a European war, distances from U.S. Army depots or ports to the battlefield were relatively short, hundreds of kilometers or less. These regions had dense highway systems. The Soviet Union faced completely different geographic realities. The distance from the Ural Mountains tank factories to East Germany exceeded 1,500 kilometers. Soviet heavy units stationed in Siberia or Central Asia might be far from rail lines or paved highways. The MAZ-five 37's off-road ability was a solution to Soviet geography, a necessity the U.S. simply didn't face to the same degree. NATO's superior road network meant American heavy trucks could usually stay on pavement, allowing the use of less exotic 6x6 tractors. Soviet planners had to consider poor infrastructure in remote areas and longer distances. They couldn't assume roads would be available or intact. The MAZ-five 37 was designed to operate where there were no roads at all. The development of the MAZ-five 37 was a state-driven program in a command economy, a deliberate decision by Soviet planners to create a specialized military vehicle. In the United States, vehicle design was often left to private industry responding to Army requirements. The M123 tractor was essentially an outgrowth of Mack's prior heavy truck designs. These were adequate on roads and easier to mass produce and maintain. building a U.S. Mule equivalent of the MAZ-537 in large numbers might have been seen as cost-prohibitive and unnecessary given other transport options. American military procurement operated under budget constraints and competitive bidding. Soviet military industries operated under central planning directives with guaranteed funding. A significant portion of U.S. heavy equipment movement was handled by rail. Tanks and armored vehicles could be loaded onto flatbed rail cars to cover most of the distance, then transferred to military truck transporters for the last leg. An American officer once observed that one of his top logistical needs was simply more flatbed rail cars for moving tanks. The U.S. Army, especially in Europe, planned to use rail as long as possible, given that Western Europe's rail network was dense and efficient. American logistics leaned on a mix of railroads and standard heavy trucks. The United States developed unique solutions that reduced the need for long-distance tank transport. In Europe, the POMQS program, prepositioning of materiel configured in unit sets, meant that entire brigades' worth of tanks and vehicles were stored in West German depots. In a crisis, U.S. troops would fly in and marry up with this equipment, obviating the need to haul tanks across Europe at all. The Soviet Union had most of its tank armies on its own soil and would have had to move them forward into Eastern Europe. Hence, they prepared to do so with trucks like the MAZ. Tank recovery was another area of difference. The U.S. generally handled battlefield recovery with armored tracked vehicles like the M88 recovery vehicle, introduced in 1961, rather than giant wheeled tractors. The M88 could tow or lift disabled tanks on the battlefield using its own tracked chassis. The MAZ-537 wasn't just a tank transporter. It also served as the chassis for mobile missile launchers. Some Scud missile systems used MAZ family 8x8 trucks. Heavy surface-to-air missile batteries and radars were often mounted on MAZ chassis. The United States did not put long-range missiles on such heavy trucks. American ICBMs were in silos or submarines. Theater missiles like the Pershing II, deployed in Europe in the 1980s, used smaller vehicles. American systems like Patriot SAMs, introduced in 1981, are towed by trucks like the M983 HMTT tractor, an 8x8 vehicle, but much lighter than a MAZ-537 and intended for use on roads. The Soviet military specialized in huge wheeled vehicles to carry strategic weapons. The U.S. found other ways to deploy such weapons, reducing demand for MAZ-537-type trucks. The 1991 Gulf War demonstrated how the American system worked in practice. When Operation Desert Shield began in August 1990, U.S. forces deployed to Saudi Arabia from bases worldwide. Tanks and heavy equipment arrived by ship at Saudi ports. American heavy equipment transporter units using M9 11 6x6 tractors and some early M1070s hauled Abrams tanks from ports to forward positions in the Saudi desert. These operations prevented unnecessary wear on tanks and allowed rapid positioning. But the HET vehicles operated on an existing road network. Where terrain was undeveloped, U.S. Army engineers improved routes. The HETs weren't required to have the same off-road independence that the MAZ-537 had. The war also highlighted American airlift capabilities. C-5 Galaxy and C-141. Starlifter aircraft flew equipment directly from the United States to Saudi Arabia, demonstrating strategic mobility the Soviets couldn't match. No MAZ-537 equivalent was needed because the system worked without one. The Soviet MAZ-537 remains an engineering marvel, a gargantuan truck that embodied the USSR's determination to mobilize massive force on land, with its tank engine and 8-wheel drive giving the Red Army practical advantages. The United States, facing different logistical realities and strategic priorities, never fielded a carbon copy during the Cold War. Instead, the U.S. relied on extensive infrastructure, railroads, advanced airlift, and conventional heavy trucks, supplemented eventually by the M1070 HET. The MAZ-5 tells a story of the Soviet strategic mindset. A massive landmass with poor infrastructure, limited airlift, and a doctrine emphasizing ground mobility required a machine that could haul heavy loads anywhere, over any terrain, without depending on roads or rails. The United States, with dense highway networks, extensive railroads, global airlift and sealift capabilities, and forward pre-positioned equipment, simply didn't need to build such a machine. Each solution was effective in its context. The MAZ-5 could drag a tank through Siberian mud. The C-5 Galaxy could fly a tank across an ocean. Different tools, different strategies, same goal. Military technology is never one size fits all. It's always shaped by doctrine, geography, industry, and strategic priorities. The MAZ-5 was the right answer to the Soviet question. The absence of an American equivalent was the right answer to the American question.